Good morning, this is your Stat Sensei, Mr. Spensei, and this is an exit ticket, and we're going to create a confidence interval for our diet plan scenario. It wants us to calculate a 97% confidence interval, so we can go ahead and fill that out as 0.97 or 97 divided by 100. All right, so a nutritionist claims that the average loss for a new diet plan is 8 pounds with a standard deviation of 1.9. So we know our population standard deviation, and it's in pounds. And they have a random sample of 35. So N is 35. And from a group of 2,500 who follow the diet plan, an average weight loss of 8.7. So we have a sample mean of 8.7 pounds. And now we're supposed to calculate a 97% confidence interval. So first off, let's write down our formula. X bar plus or minus Z star, standard deviation of the population divided by the square root of n. Now we're going to calculate Z star. All right. So if I'm calculating Z star, I'm going to go second vars, inverse norm, and I'm going to plug in the confidence level, which happens to be 0.97. And we're looking for a Z, so all mean is 0, standard deviation of 1. So this is an inverse norm, 0.9701. This is my PMS, my probability, my mean, my standard deviation, and we want center. We have a Z star equal to, and all we care about is the positive value is 2.1700. All right. So 2.1700. So now we're going to plug into our formula. Well, we know X bar is 8.7. So we have 8.7 plus or minus Z star 2.17. And we have our standard deviation of 1.9. So that's what they asked for next. Next thing they asked for is a sample size, which is 35 over the square root of 35. So now we've plugged in. We're going to go ahead and run this thing. And we are skipping some steps only because we defined the parameter and calculated and verified the conditions in the assignment itself. So no sense doing that twice. So here we go. Stat test. We're dropping down to Z interval, which is number 7. And I have to put in some data. All right. 1.9, 8.7, 35, and we need to change that confidence level to 0.97. We calculate, and I end up getting an interval of 8.0031 all the way up to 9.3969. And what this tells me is we expect them to lose well, this is a little bit over 8 pounds, a little over 8 pounds to as much as 9.4 pounds. All right, that's what it tells me. So the true population average is somewhere between there. Okay. We should notice it doesn't contain the original 8 of their claim, which means it is above it. So conclusion, we are 97% confident that the true population mean weight loss lies within the interval. And we just need to list our interval now, 8.0031 and 9.3969. All right. Now, one thing I can say is this right here, the true population mean weight loss, that came directly from when we defined our parameter in the assignment, in the prior assignment, right? Because in the prior assignment, we said let mu equal the true population mean weight loss, and that's exactly what we have down here as well. All right. I hope this helped. Look forward to seeing you on the next one. Thank you.